Hi guys, I am here again with my new video on physics topic. I had uploaded one of my physics videos previously. I remember, so it was on friction. Today we are going to discuss about distance and displacement. So let's start the video with charming and interest. So friends, we all can see that here is a triangle and this is a right angle triangle. Here there are three parts of a triangle. We should all know that its height, base and hypotenuse. This is the height. Wait just a minute. This is the height. It's written here already. And this is the base and this is the hypotenuse. So we have learned that there are three parts of the triangle, and next we are going to learn about our main topic, distance and displacement. So let's start. Here you can see that the hypotenuse is 20 and the base is 12 and the height is 16. Now I am calculating it as meter since the displacement and distance has the SI unit of meter. So I am calculating it as meter. Now next we are going to learn about distance and displacement. Now you can see that the blue line drawn here is the hypotenuse and it is 20 meter. Next I am wanting to tell you that it's very simple and clear that the hypotenuse is the displacement. So we can define displacement as the shortest possible distance covered by an object from its initial position to its final position in a particular direction. In the scalar quantity and vector quantity we will learn about all those, but now I want to tell you that suppose this is a road, this one is a road, and hold it this point as the initial position and this one as the final position. Now it is the shortest possible distance. If you think that it's your friend's house and your house, you go from your friend's house from your house to your friend's house. It's the shortest distance. So it's much clear and fine. Next we will learn about distance. Here we go. If we calculate the height and the base, we will get 28 meter. And this 28 meter is the distance. How interesting. So we can define distance as the total length of the actual path. No, it's the actual path, but this one was the shortest way. But this is the actual path to go from initial position to final. That is, if you consider, I told you that this one as your friend's house, as your house, and this one as your friend's house. So it's the actual path covered by an object irrespective of its direction. So now you see it's going from here and again from here to there. So is there any specific direction? No, there is no specific direction for this way. So for that reason, in the definition it's mentioned that irrespective of its direction. And you know that distance is denoted by the letter D, since distance starts with D. So in simple words we can say that displacement is the shortest way and distance is the largest way. Now, as I said, now we are going to learn about scalar and vector quantity. Scalar and vector quantity are very interesting and also very important. So, without wasting much time, let's proceed to our discussion. Scalar quantity and vector quantity. Scalar quantity is that quantity which have magnitude but no specific direction, and vector quantity is that quantity which have magnitude as well as direction. Now let us take some examples of scalar quantity. Scalar quantity examples are distance, time and speed. Now, if you remember, I had previously stated and discussed that distance has no specific direction. In the definition also I said that irrespective of its direction. So, we can match it completely with scalar quantity, because scalar quantity has no specific direction and therefore distance is a scalar quantity. Now time. Let's take the example of time. Time is also a scalar quantity because it has specific magnitude but no specific direction. When we mention time, do we say that according to this direction or that direction, this time is happening? We don't know. So, time is a scalar quantity. And the next example is speed. Now, distance is related to speed because without distance there will be no speed, isn't it? And since distance is a scalar quantity, speed will also be a scalar quantity only. Therefore, our next examples will be of vector quantity. Now let's take the example of displacement. I had previously stated that we will learn about scalar and vector quantity later on when we were discussing about the definition of displacement. It was stated that it's along a specific direction. So, to understand better, let us take that photo once again and see. I had stated previously only that if you suppose this one as the initial position and this one as the final position, so this is the shortest way. But notice here carefully that it's going along a particular direction, and I say that this is your house and this is your friend's house, and so you are going from here to here, and so it's along this direction. So we can say that it's a vector quantity very clearly because it's going along a particular direction. It will not go upwards but only downwards. Because this one is your house and this one is your friend's house. For that, and you are not going from your friend's house to your house. You are going only from your house to your friend's house. So at that time, the displacement's direction will only be downwards. Other examples of vector quantity are velocity, force, etc. When we take the example of velocity, we know that velocity has a particular direction and also particular magnitude. Therefore, we can say it as vector quantity. And next is force. If we take force as example, we can say so that it takes a specific direction. It moves on a particular direction. When force is acting on a body, we can see that the direction is particular and also the magnitude is also specific because we can calculate it on a spring balance. Now we are going to discuss about difference between one example of scalar and vector quantity, and that is, let's see. We all know that mass and weight are different terms because mass is the amount of matter contained in a body and weight is the force with which the earth attracts a body towards itself. So, weight is a force, and I stated previously only that force is a vector quantity because it has specific magnitude and direction. Therefore, we can state clearly that weight is a vector quantity. But what about mass? Mass is a scalar quantity because mass has specific magnitude but no specific direction. We don't say that this direction and those direction of mass. We don't tell, no. For that, mass is a scalar quantity. So that was the difference for which we were waiting. So in my video, I think it's clear to you what is distance and displacement, scalar quantity and vector quantity. Thank you.